Hi, welcome to our next set of notes. As I was thinking about these notes, I was remembering the conversation that I had with my brother the other night. I have an older brother, and he was reminding me of some of his stories from back when he was in school. And one of the times that he got in trouble, he was in the principal's office, and the principal was said, "This is the fourth time you've been in my office this week. What do you have to say for yourself?" And my brother responded, "I'm so glad today is Friday." And so the principal did get a good kick out of that. Luckily, no extra discipline for that one. It was just he threw his peanut butter and jelly sandwich onto someone's hair, like open face. So that's why he was down there for the fourth time. So anywho, let's move on and talk about these next notes. We have inequalities. So we are now switching gears, talking about inequalities. It's a mathematical sentence that compares two unequal expressions. So what we had before, they were equal. That's why we had the equal sign. Now we have unequal expressions. What we're going to go ahead and start with is just talk a little bit about the meanings here. So we're going to use an open circle. We'll write this in. For less than or greater than signs, okay? And so this is what I mean by an open circle. The open circle, squeeze that in there, means that the number is not part of the solution set. Thus, it is not shaded, not highlighted. We'll be doing some highlighting today. We're going to use a closed circle for less than or equal to, greater than or equal to signs. The closed circle means that the number is part of the solution set, thus it is shaded, and when we highlight, it will be highlighted. And I almost forgot to draw in. That's what I mean by a closed circle. Okay? So problem solving tip, notice that anytime you say equal to, the dot is closed, otherwise the dot is open. Therefore, open dots are less than and greater than, closed dots are less than or equal to, greater than or equal to, and also equal to. Ooh, for some reason the font, the formatting did not put that in there. So let's go ahead and put that in there. Open dots are less than, greater than, and not equal to, and we'll do some examples of what that looks like today. Closed dots, and this is key right here to remember this. You know what, if you don't have a highlighter, grab one. We're going to need it for today's notes. So go ahead and highlight that. This is important. Okay. Number one, okay, we're going to just do some practicing with on a number line. So we have x is less than 3. So we're going to find 3. We're going to do this right above. And less than. Now the solution for this one, this is what we're going to highlight. The solution is what we highlight. Okay, notice I did not highlight the open circle. Number 2, again, we're going to find -1, greater than, so these are all values greater than -1, and I'm going to go ahead and highlight that. So again, this is part of my solution set. Number 3, at number 4, this is greater than or equal to, so it's a closed circle. Values greater than or equal to 4 go to the right. When I highlight, I'm going to include my closed circle because that is part of the solution set. Whoops. Number 4, at -6, that's a closed circle. It's less than or equal to, so this is going to be values less than or equal to -6, so to the left. And when I highlight, I'm going to highlight that closed circle because, again, it's part of the solution set. The next part, we're going to write an inequality, okay, for these graphs. So for number 5, it's at 13. You have to use a variable. It doesn't matter which one. I'm just going to use x. And my values, it's going less than 13, so less than, it's open, so it's not equal to, so x is less than 13. Going across to number 6, I have x. It's a closed circle, so it's going to be equal to, and at 7, and I'm going to do it right underneath so I don't run out of room. And again, my values are greater than. There we go. Number 7, again, I'm going to have my variable. Then I notice it's at negative 18. It's a closed circle, so it includes it, and it's my value is getting smaller, so less than or equal to. And then number 8, we have x, our variable. It's an open circle at 10. Values are getting greater than, so just a greater than sign. Okay, so that's the first page. Let's go ahead and given the word sentence, we are going to be writing and graphing an inequality. So we'll be making some number lines. And for some reason, I started over at number 1. Did not mean to do that. Anyway, y is less than negative 4. So we're going to use the variable y. Less than, here's the less than symbol, negative 4. Okay? When we create our number lines, you need to have at least 3 numbers. So negative 4, negative 3, negative 5. It's an open circle. It's less than, so my arrow is going to go to the left or go towards the less than values of negative 4, and I'm going to highlight my solution. Okay, going across to number 2. K is no more than 7. So I have K no more than 7. So to represent no more than, 7 has to be my greatest value. It can equal 7, but it cannot be any greater than. So let's create that number line. It's a closed circle, so I'm going to have that closed dot, and it's less than, so I'm going to go towards where my values go less than 7. When I highlight, I'm going to include that closed circle. Number 3, P has a minimum of negative 5. So I have a P. I'm going to have negative 5 minimum. So that means that negative 5 is my smallest value. P is going to be all the ones greater than. It can equal it. So we have next my number line. So I have negative 5, negative 4, negative 6, closed circle. And it's going to be all numbers greater than negative 5, so arrow in that direction. My solution is the closed circle, so I'm going to highlight that. Now, number 4 we're going to talk about when I see you next time in class. Now, if you just now were struggling with, ooh, I don't know what signs those 3 are, we'll go in class onto my website, but you can always do this ahead of time, is go to Unit 1B, Inequalities. Once you click on that, you'll see a great list of words and which inequality it translates to, okay? But again, we'll also talk about that in class. Now, the next thing that we're going to do is we're going to practice solving these and graphing these. So before we get started, a couple of rules for solving inequalities. You must flip the inequality symbol when you multiply or divide by a negative number. Okay, that's one of the rules that we're going to remember with inequalities. So let's go ahead and get started with number 5. So for number 5, to solve for x, we'll start by subtracting 2 on both sides. We get 3x is less than negative 6. Then we divide both sides by 3. We are not dividing by negative, so no flipping. My answer is x is less than 2. My number line, same thing. As the top 3 values, it's an open circle. It's less than, so that direction is all my less than. And I'm going to go ahead and highlight my answer. My highlight represents my solution. Okay, and that'll be very important in just a few sections, and that'll be necessary. Well, anyway, let's move on to number 6. On number 6, to get x by itself, we're going to start by subtracting 2 on both sides. I get x over 6 is greater than negative 3. To solve for x, I'm going to go ahead and multiply both sides by 6. I'm multiplying by a positive value. I don't need to flip, so I have x is greater than negative 18. This is my answer, and then the next thing I'm going to do is draw my number line. And so let's go ahead and mark that it's an open circle. They're greater than values, so arrow to the right. There we go. Number 7. So for number 7 now, to solve for x, we're going to start by subtracting 8 on both sides. I have negative 7x is less than or equal to negative 12. From here, to solve for x, I'm going to divide both sides by negative 7. So as I am dividing both sides by negative 7, I'm going to flip that sign, and my answer is going to be 12 over 7, but I can also rewrite that as a mixed number, which might make it easier when we're graphing. So 1 5/7. Okay? There we go. On my number line, 1 5/7. Greater than is going to be 1 6/7. Less than is going to be 1 4/7. It's a closed circle this time. It's greater than, so my arrow to show greater than values. And my solution includes the closed circle. It's everything to the right. All of my numbers to the right of 1 5/7. Okay, so again, on this one, remember we divided by a negative, so we flip that sign. So very important rule. It's going to be the last step as we're solving for the variable, and we're multiplying or dividing, and it's a negative number, flip that sign. Okay, so definitely important. And if we're highlighting, let's go ahead and mark that. There we go. Okay, I know the highlight isn't showing up too well. All right, the last section that we're going to practice together is going to be right here, where we are going to just write an inequality. So the directions say just write an inequality. And so you'll see that on the notes sometimes, and you'll see that down below. We'll write and solve. So for number 9, a number increased by 6 is less than 9. So for this one, what we're going to do is any variable, when they talk about number, you can use any letter. So I'm going to start with x. Increased by 6, so plus 6, is less than 9. Let's move on to number 10. 6 times a number is no more than 9. So that'll look something like 6x. Okay, no more than 9. So that means that 9 is going to be my greatest number. It can equal 9 since it's no more than. Okay, let's try number 11. The opposite of 6 times a number is at most 9. So the opposite of 6, that's going to be your negative 6, times a number is at most 9. So again, at most 9, very similar to number 10, where we are not going to be going greater than 9, but we can equal 9. Okay, so kind of think about this, talk these out as you come up with your which symbols do I use. Number 12, I have 1/3 of a number, so 1/3 of a number is at least 9. Okay, so it's that 1/3 of a number is at least 9. Okay, so that means that we are not going to be going less than 9. We're just going to be going greater than 9. All right, and we'll talk about 13 and 14 in class, and that's when I'll try and show you what I have on my website. Now, number 15, the last one that we'll do on this video today, is this story problem. So we'll be doing some story problems. So we want to make sure we define the variable, set up the inequality, and solve. So these directions on this homework assignment will be very important, so you're doing what you need to do. A high school drama club is performing a musical to benefit a local charity. The tickets are $5 each. They also received donations of $565. They want to raise at least $1,500. So let's go ahead and figure out, and I think I forgot to put on the question, how many tickets do they need to sell? So let's go ahead and I'll be more clear on the homework, so I apologize. So we'll have X equals tickets. Okay, that's what we're looking for, is how many tickets can they sell. If they are $5 each, okay, it's going to be 5 times X. Okay, and then they have donations of $565, and they want to raise at least $1,500. So it'll be at least $1,500. So this is kind of, we're going to figure out how many tickets they need to sell to raise that amount of money. Here's your inequality, and then let's go ahead and solve. We'll subtract 565 from both sides. We have 5x is greater than or equal to, when I subtract, I get 935. Divide both sides by 5. I have x. We don't flip it, so it'll remain x is greater than or equal to. Since we divided by a positive, we don't need to worry about flipping. And when we do this, 5 goes into 9 once. My remainder is 4. Then I get 8. My remainder is 35. There we go. So they need to sell at least 187 tickets, and we're going to write this as a sentence. That at least, that's important, the key word, at least 187 tickets. Alrighty, that's it for these notes. I'll see you guys next time in class. Over and out.